Good evening to you all. We thank God for another opportunity to share this presentation. Yes, we have discussed about textile fibers, their characteristics. So today we want to discuss about vegetable fibers. We discuss fibers that they are categorized into two. That is man-made fibers and natural fibers. And we realize that the natural fibers are subdivided into three. The plant fibers, the protein fibers, that is animal fibers. Then we have the mineral fibers. And that of the man-made fibers are also subdivided. We have the synthetic fibers and regenerated fibers. We have explained all that. Okay. So we are coming to discuss about vegetable fibers, or for that matter, natural fibers. Okay. But before that, this is your group presentation. So I'm giving them to you so you prepare in advance. And as you know, my group presentations, each individual is supposed to do the work, and then you arrange for a meeting according to your groups. So when you are coming for the meeting, you have your answered question so that through what you have answered, you all come together and prepare one presentation with your findings representing the group. So I take the individual ones, then you do the presentation, and I'll take that one too. So this is your presentation. What are care labels? Care labels. Their importance. Their importance. Then we have international care labels. That is generally accepted. We want to find out what is it. Then after that, differentiate between blends and mixtures. Blends and mixtures. With your knowledge of care labels, differentiate between blends and mixtures. Then demonstrate three methods used in fiber identification. So using burning test and two others. So you can use cotton, silk, or wool. That is the protein fibers. Cotton is a plant fiber. Then animal fiber, then man-made fiber, and regenerated fiber, that is the rayon. Then why do you think fiber identification test is necessary? This is the one of your presentations. Okay, so now let's move to vegetable fibers. So what are vegetable fibers? The fibers obtained from plants are termed vegetable or cellulosic fibers. They are primarily composed of cellulose. So cellulose is a compound consisting of carbon, hydrogen, and oxygen, which constitutes the basic material of all plant life. So vegetable fibers derived from cellulose share common traits like resilience, high density, and excellent heat conductivity. So these are the common traits all cellulosic fibers share. So they are also highly absorbent. They absorb water and they can withstand high temperatures. So we have examples of vegetable fibers being cotton, flax, jute, rami, and many more. So let's look at certain vegetable fibers. We have jute. It's a stem fiber. Jute is a stem fiber. We discussed that the plant fibers are still divided into three. So we have those we get from the seed, example is cotton. And those we get from the stem, the cotton stem, example is jute. Another is flax fiber, the fiber that produces the linen fabric. Then we have the leaf, example is sisal. So these are the three examples of plant fibers. So jute is under stem fiber. It's used as a good source of bagging cocoa. So you have jute bag, cocoa jute bag. Now it is not all that common. You used to bag sugar, coffee, rice, and for the production of cordage, the cordage that we use for drying our items, twine and carpet backing. So jute is ranked the second most widely used vegetable fiber next to cotton. The next example is kapok. Kapok is a seed fiber. That fiber that flies and gives us Apollo. Okay, so it's an example of seed fiber, just like cotton. It is very short in length and very lustrous. It shines and very light in weight. Because of that, it is unspinnable. You cannot twist it. So it is used to produce mattresses and pillows. But now we can use it for regenerate or as regenerated fiber because we can add chemicals to them and change the original formation into a new one. Because it is also very short, we can use them to produce parachutes. The next one is quail fiber. It's a seed fiber extracted from the outer shell of coconut. After you have taken the best fruits, the leftovers, it is commonly used for making cordage. Coarse cloth, that is for carpets, because it's very hard, very bristle. So you use them for making brushes. It is not body friendly, but that one too, you can use them for making regenerated fiber. So now we are taking one of the seed fibers, that is cotton. We want to see how we can process cotton fiber into yarn and into fabric. So cotton is the world's most important fiber, most important widely used natural fiber. It has achieved this popularity because it has a combination of desirable properties which favor the great number of people who live in warm and subtropical planets like you and I here. The weather is hot, but because of the cotton, the properties in cotton, we are able to use it and we become comfortable. We'll discuss more about it. Cotton, known scientifically as gossypium, that's a scientific name, has been used since 12,000 BC. It originates from Egypt and presently China and United States are the leading cotton producing nations. Cotton is short in length, and that is referred to as short staple or linters. We have the very short ones are called staple fibers. The cotton is itself is a short fiber, but we have very short ones, and the very short ones are called short staple. And then the long ones that we can put together and twist to get the yarn are called lint. So short staple or linters, then the long staple or length. So it's the length that you use to produce yarn. So let's look at the cotton, the matured cotton on the cotton plant that we can use for making yarns. So this is how cotton looks like when it is matured. So on the cotton plant, this is how you see it. So this is cotton, ripe cotton. Then this is kapok, the one that gives us Apollo. Okay. So you have types of cotton. You have sea island cotton. You have tree cotton, lavand cotton, Egyptian cotton, and many more. So generally, cotton is durable and easy to wash. It is absorbent and can regain 85% moisture and good for perspiration. It is porous and allows free circulation of air, which renders it cool and therefore comfortable to wear. It is highly deteriorated by the action of acid, which causes the formation of hydrocellulose. It does not itch the skin. It is good conductor of heat. It is resistant to alkaline. So when you are dyeing, we don't we use alkalines as chemicals or as mordant. So it means that it is not good when you use acid. When you use acid in dyeing cotton, you destroy it. So these properties of cotton make it an excellent fiber for heavy workloads because air can pass through it. You wear it, you feel comfortable. And when in the hot, scorching sun, you are sweating, it can absorb the sweat. So when you look at cotton using the microscope, this is how cotton looks like. Cotton have wavy nature. Uh, it is not straight. So the wavy nature is a good quality when it's come to spinning because they can cohere to one another and we can twist them to get a yarn. So when you look at it, it has convolution. Okay, so this shows a matured cotton. It looks like bean. So this is immatured. You can see it here. So this one means that it is dead. It was not able to mature. So here, when you put cotton in caustic soda or base, it assumes a cylindrical shape. Cotton is a very dull fabric, but after menstruation, it becomes lustrous. And that is the reason. So it is like this. But when you put it in caustic soda and hydros, they assume, or caustic soda to be precise, caustic soda, they assume cylindrical, and yes, they assume this cylindrical shape, and that makes it um, lustrous. Okay. So when you look at cotton using the microscope, yes, this part is what we're seeing here. Let's look at it here. Okay. So here you can see it very well. So that's the cross section of the cotton fiber. The top here, when you cut cotton. Okay. So here you see the wavy nature I'm talking about, and that is called convolutions. So when you look at cotton, the outer shell, just like your skin, the outer skin is called the cuticle. So beneath the outer skin, we have the primary wall, the primary wall. Then beneath the primary wall, we have the flesh. Your flesh, when you cut your skin, first of all, you see the very lighter skin. Then beneath the lighter skin, you have the back. The back is the primary wall. Then beneath the back, we have the flesh. That is the secondary wall. Okay. So at the middle or at the center, we have the lumen. The lumen nourishes the fiber. Okay, so you're not going into detail. But this one can come in your exams. The cross section of the cotton fiber. Okay, so how do you process the cotton fiber to get the yarn? First of all, we need to harvest the fiber, the ripe fiber from the cotton plant, the one I showed you. So the first process is harvesting or picking from the cotton plant. So the ripe bulbs, having matured fibers, as I've shown to you, are picked by machines in developed countries. And now we are also developing. So you can also use the cotton, the machines to pick cotton. Or we can also pick them by hand. The chemical picking is very fast. That is the using machines. And co-effective method of harvesting. Machines are used, the machines used are called picker or striper. So this is one of the machines that a combined harvester. Then we have the hand one. Here we are using our hand as a machine to pick. When you use our hands to pick, it's very neat as compared to the combined harvester that picks both the fibers and that of the leaves. So after picking, the next is ginning. And what is ginning? Ginning is taking away the seeds in the cotton. The cotton has seeds. So we need to clean the cotton. So the first cleaning is taking away the seeds. And taking away the seeds is called ginning. So after picking, the cotton is sent to a ginning machine where it is ginned and is simply taking away the seed from the cotton fibers. So ginning the separation of the seed from the fiber, it is done by a machine called saw gin or the McCarthy gin. So the short fibers, as I've already discussed, that the linters are used for the production of mattresses, cushions, fine paper, and a useful source for cellulose for conversion into viscose, that is the regenerated and acetate rayon. The gin cotton fiber known as lint, that's the long fibers or the long staple, is then compressed into bales. The cotton seed is pressed into cooking oil, so you don't throw anything away. The husk and seeds are processed into animal feed and the stems into paper. So you see, cotton is very useful. So after this, we compress the cotton in bales. So the highly quality cotton fibers known as the lint are pressed and baled, typically wrapped in hosien cloth, a strong coarse fabric made from hemp or jute and secured with wire or iron bands. This compacting process reduces the bulk for easier transportation to the spinning mills. So now you send them to the mills. So when it gets there, we need to open it and work with it. And that is, we need to break the bills. So at the spinning mill, the bill cotton undergo spinning or opening, undergo opening and cleaning using a machine called a bill breaker. This equipment loosens the cotton fibers and removed heavy impurities like broken seeds, husk, and dirt, as well as lighter impurities such as dust and immature short fibers. So this is cotton in bales. So we pack them in bales like full bales. Then they are sent to the industry. So when you get to the industry, you have a machine called a bill breaker that will help us to break it so that we can have the fibers to work with. So that is the bill breaker, breaking the bills so that we can get the fibers to work with. So after breaking, we see cotton having different colors because they are coming from different places, different length. So we need to open them and mix them. So the function of the opening machine is to open out the cotton as much as possible and to remove both light and heavy impurities. The cotton is therefore passed through machines such as vertical and horizontal openers to achieve these results. There is a need to mix cotton to bring about some sort of uniformity in the bulk of cotton because cotton from even the same film varies considerably in quality. So this comes about because of differences in the natural conditions such as sunlight, moisture, etc., which affect growth of the cotton. So different types of cotton are therefore mixed to produce a good quality cotton for yarn production. Care is, however, taken in mixing because it needs specialized knowledge. So after mixing, now we need to go through scratching. And this one is an old system. Now, because of machines, we don't use this one again, but we need to know what is it. So scratching refers to the process of cleaning cotton of its seeds, husk, leaf, and other impurities. So this one, the cotton is opened and air is blown through it. So all the heavy impurities will just come down. And after that, the cotton, the fibers are compressed. The fibers are compressed. You allow the fibers to settle, then you compress them into a sheet-like. Then you roll it like a tea roll. Okay. So after opening and cleaning by the openers, the cotton is passed through the scratcher machine, whose duty is to continue to convert the fibers into a compressed sheet. And that sheet, that compressed sheet is called lap. So this is wound layer by layer in the form of a roll, and then it is sent to the next machine called the carding machine for further processing. Okay, so this is how it used to be done. So this is the carding machine. So what you have up there is the lap, which has been rolled like a tea roll. It has been packed. So the carding machine inside here will open the cotton again, then take away extra impurities, and then it will come out as a sliver with a little twist. So the slivers are packed into these barrels for the next process. So that's the carding machine. The main purpose of the carding machine is to lose the fibers, then take away extra impurities, clean it very well, then align the fibers one after the other, then put it in a rope-like form. So like the cylinder in the cylindrical shape, then they are packed into barrels like this. Okay. So now that system is now old system. What we have now is called the blow or the blow room. So the blow room is just one machine, and it can do a whole lot of things, and the fiber will come out as a saliva. So the blow room, the bale cotton is sent to the blow room for the cleaning process. The blow room's primary function include opening, cleaning, dust removal, blending, and evenly feeding the material into the card or into the carding machine. So this is the new system. So the main purpose is to open the baled fibers into little tufts, allowing foreign material to be removed from the fibers and preparing the material for easy carding. So the blow room process takes away the scratching and all that. So the fiber is fed into the blow room machine, and it will clean everything, and the fiber will just come out as a saliva. So that is the blow room activities. So auto bill plucker, condenser, and all that. So the fiber will come out as a carding it will feed it into the carding machine. So from the blow room, it will feed the fiber into the carding machine. Then the carding machine will continue the process to drawing, to roving, to ring spinning, then into the packaging, that is the cone uh, winding. Okay, so this is the blow room process from the breaker to the carding. Okay, so that is the end of the carding machine. So the fiber stage, it will come as a saliva. From the fiber stage, it will come out as a saliva. That is the something like your hand with little twist. Okay, so for that, we move to what? We move to the drawing machine. But mind you, we have the carding. After carding, we have the slivers, carded sliver. But the carded sliver too, we can comb it. We can comb it to take away short fibers. So combing is an optional operation. When we needed the the fabric to be very fine, having a very fine surface, we do combing. So combing is taking away very short fibers, resulting in just the length, so that when you produce the fabric, it has a very fine surface. Okay. So after that, we have the combed sliver. So card sliver, then you have the combed sliver. Okay. So these are the slivers. It can be combed or the card. So we have the slivers. So we take about 1, 2, 3, 4, 5, 6 of the slivers and put them together. Then we hold. We we twist, we pull and twist to get our first what moving. So let's see. Okay, so more about the carding. It is the process done to loosen the fibers and further removing unwanted material and separating one fiber from the other. The main aim of the process is to lose the fibers and also remove impurities like leaves, sand, stalks, broken seeds, husk, dirt, etc. However, the process is not done effectively, and that a lap, that is the scratching, still contains impurities, which may be short fibers, immature fibers, stained fibers, and broken seeds. All these impurities should be removed if a good quality cotton is to be produced. So the function of the carding machine is to eliminate these impurities, separate one fiber from other, and then convert the lap into a loose cylindrical rope, and that rope is called sliver. So that's the spelling of the saliva. So after carding, you get saliva. Okay. So this is the combing. It is an optional operation, but it is used to remove the short fibers, creating a stronger yarn. And that will give you a very hot, fine surface fabric when you use just the combed slivers to produce the yarns. So each sliver will have thin and thick spots, and by combing several slivers together, a more consistent size can be reached. Combing several slivers produces a very thick rope of cotton fibers, combed, and that is the combed sliver. The resultant fiber is called combed sliver. So from there, from the slivers, combed or card, we feed the drawing machine with these slivers. Okay, so the drawing process uses the machine called draw frame to ensure that the individual fiber from the card sliver lie parallel to one another. For good quality yarns to be produced, the fibers must be well cleaned and arranged and made more parallel. This is done to eliminate irregularities that might cause variations in the yarn. So during the drawing process, two main actions take place. And these actions are one, combination of several slivers into one, and that is called doubling. So we combine a number of the slivers together to bring about uniformity along the length of the resultant saliva. So after putting a whole lot together, the next action is to attenuate, that is the attenuating or thinning, that is pulling, that is, okay, thinning down of the fibers called drafting to make them parallel. So the two main activities or actions is doubling. So the doubling is where you double a number of the slivers together, about 6 or so. Then drafting is where you pull the number of slivers so that as you pull, you twist to turn it to become very small. So during the process, the sliver received its first twist, just sufficient for further processing without break. Okay, so the resultant fiber is called roving. It's about pencil size and wound onto bobbins for twisting into yarns. Okay, so this is the roving. So we are now going to twist these ones. You take a number of them, then you twist to get the yarns on the bobbins here. Okay. So the roving, it is the final product of the several drawing operations. For the drawing operations, you have the two actions, doubling and drafting. After that, you get a roving. So it is the preparatory stage for the final insertion of twist. So this is where the drawn saliva received its first twist, just sufficient for further processing without break. That is the roving. Okay. So after that, we do the actual spinning. So what is spinning? It is the final stage of the yarn production. It is the twisting of fibers to form a yarn. And this is done by the ring frame. They, the yarns are then wound onto bobbins. So from the roving, we send the rovings to the ring frame, and then the ring frame will twist the fibers, the resultant fibers, or the roving will twist the roving to get the final yarn. And the final yarns are called singles. They are not hard, and the best we can use them for is for weaving. It's for weaving. We can't use them for sewing because they are very soft. So after that, we need to package them. So one of the main reasons for winding yarns is to obtain longer length of yarns to permit the continuous production of the long length fabrics. So the length of the yarns are wound onto special package, such as cheese cones, pens, and bobbins. So these are cones. Let me explain it better here. Okay, so the cheeses, the top and the down are the same. So what is inside the top and the down are the same. So when you produce the yarn, they take the same position. Then you have the cones. These are the cones. The top is smaller than the down. So what is inside is shaped like that. Okay, so you have the hands. The hands, you use them next semester. In the olden days, this is how you used to package our yarns. Now we are in the modern world. So this is how we package for weaving in the industry. So these are called pens. Okay, so let's look at the characteristics of the cotton fibers. So we have the physical characteristics, we have the chemical characteristics. Okay, so we can see color. Color, you can see it. So it's a physical characteristic. The color of cotton fiber will be white, creamy white, bluish white, yellowish white, or gray. So the tensile strength, talking about how strong the fiber is. Cotton is moderately strong fiber. It has a tenacity of 3 to 5 grain per denier, gram per denier. The strength is greatly affected by moisture. It means when you put them in water, it loses its strength. The wet strength cotton is 20%, which is higher than dry strength. So it means that when you put cotton in water, it becomes more stronger. Okay. So elongation at break. Cotton does not stretch easily. So it is inelastic. It has an elongation at break between 5 to 10%. When you stretch it small, you force it, it will break. Elastic recovery. Cotton is inelastic and very rigid fiber. So the gravity is 1.54. So let's look at the chemical properties of cotton. Effect of acid. Cotton is attacked by hot dilute acid or cold concentrated acid, which disintegrates cotton. So cotton is not friendly to acid at all. So when we are processing cotton, you use base or alkalines. Effect of alkaline. Cotton has an excellent resistance to alkalines. It swells in caustic soda or caustic alkalines, and that makes it when you use it for mercerization, the mercerization, because it swells, it makes it lustrous. Either than that, cotton is a very dull fabric, but after mercerization, it becomes lustrous. It shines. Okay. It can be washed repeatedly in soap solution without any problem. You can testify this. Effect of organic solvent. Cotton has high resistance to normal cleaning solvents. Effect of insect. Cotton is attacked by moths or beetles. They can eat them because they are coming from plants. Effect of microorganism. Cotton microorganism. Cotton is attacked by fungi and bacteria. Mildews will feed on cotton fabric, rotting and weakening the materials. So mildews and bacteria will flourish on cotton under hot and humid condition. When you put it at a very hot place where uh, it can have this a very hot place, it can produce this mildew because it will produce some, it's like the perspiration, right? Okay, so, okay, so moisture regain. Standard moisture regain is 8.5. standard moisture regain of cotton is 8.5%. Cotton fiber is very absorbent due to the presence of some special groups known as the OH, that the hydroxyl groups in its polymer. Okay, I will not go into chemistry. Okay, so chemical properties of cotton, effect of heat. Cotton has an excellent resistance to degradation by heat. Effect of sunlight. There is a gradual loss of strength when cotton is exposed to sunlight and the fiber turns yellow at the scorching sun. Dry cotton at the scorching sun, it turns yellow. Effect of age. Cotton shows a small loss of strength when stored carefully. After 50 years of storage, cotton may differ only slightly from the new fiber when you store it under a good condition. Okay, so we will end here and continue another time when we will take one of the stem fibers and you will discuss that one to how to produce it or how to process it to get the yarn. Thank you and see you.